Okay, so one of the many reasons that I'm making these videos is just to tie in some loose ends that you possibly have as prerequisites to this class. So one of the things that you're supposed to have knowledge of, mastery of, hopefully, before you enter this class are ranges of inverse trig functions. Now, if you don't, it doesn't matter. I'm going to re-explain it. So when you have arc tan of x, okay, every kid in this class needs to know that that graph, okay, looks like the following. Okay, there's a horizontal asymptote up here at y equals pi over 2, and there's a horizontal asymptote down here at y equals negative pi over 2. Now, we don't include the endpoints, okay, so for arctan x, we're going to be going from negative pi over 2 to pi over 2, not including the endpoints. Now, arc sine. Arc sine x. Okay, so I'm doing the ranges here. Okay, so arc sine. Now, this graph isn't likely to come up on the AP exam. Okay, but this graph looks like the following. Starts off like this, then it turns around and goes this way, okay? Now, the endpoints are included here for the range. And so, okay, when x is negative 1, we're at negative pi over 2. And when x is 1, we are at pi over 2. Now, what this means, by the way, when we say arc sine of 1, for instance, so if someone says arc sine of 1, what this question is asking you is, what angle, okay, on this interval, negative pi over 2 to pi over 2, has a sine value of 1. So, where does sine have a value of 1 on this interval? Okay, at pi over 2. So, therefore, arc sine of 1 is pi over 2. You see? Okay, arc cosine x. Okay, so that graph, okay, looks like the following. So at 1, the value is 0. At negative 1, okay, the value of this graph is pi. Okay, so this is a height of pi. Negative 1, pi, 1, 0. Okay, so the range is 0 to pi. Let's take a look at a few questions and just see if you know how to answer these. So let's say we said, okay, so this is all review, guys. I haven't done any calculus here. Okay, arc sine of a half. So what this means is what angle, okay, on negative pi over 2 to pi over 2 has a sine of a half. Okay, so the answer is that arc sine of 1/2 is equal to pi over 6. Okay, so you have to be prepared to answer questions like this. All right, I can't do every question in existence, but we'll do a couple. Okay, let me do a few more. Okay, arc cosine of a half. So you have to be on, so this means the angle on 0 to pi. You see why you need the range memorized? Okay, the angle on 0 to pi, which has a cosine of a half. Okay, so the answer is that arc cosine of a half is equal to pi over 3. All right, take a look at a couple more. So let's say we want to know, okay, what is arctan of square root of 3? Okay, so where on this interval is sine over cosine equal to square root of 3? Well, when sine of x is square root of 3 over 2, cosine of the same angle would be a half, right? Where does that occur? Pi over 3, yes. So the answer is arc tan square root of 3 is pi over 3. And that's because sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is a half. Okay? So that gives us square root of 3, and that is the tangent of pi over 3, because tangent is sine over cosine. Okay, other things, other prior knowledge that you should have are questions such as, okay, this is still prior knowledge. It's going to end up being a long video, but you can, skip through anything you already know. Okay, but if you don't know it, it is an opportunity to know it. So let's say you have the sine of arc tan of 3/4, for instance, right? So arc tan of 3/4, I'm going to draw a little triangle here. So if I call this theta, tangent is opposite over adjacent, right? So if that's 3 and that's 4, by the Pythagorean theorem, this side is 5. So the sine of arctan, 3 over 4, okay, would just be 3/5. Okay, because you draw this picture, and then the sine of theta is now 3/5. Okay, we'll take a look at a more complicated one. So, okay, let's say we have a negative one. Okay, let's say we have something like secant arc sine negative 4/5. So for this picture, okay, we want sine to be negative 4, okay, over 5. So I'm going to draw the triangle down here. Here's my theta. This is negative 4. This is 5, okay? So this is going to be 3. And so secant is the reciprocal, right, of cosine. So cosine, as you know, is adjacent over hypotenuse. So the secant is going to be hypotenuse over adjacent, right? So the hypotenuse over the adjacent here is 5 over 3. Okay, what about when you have some variables involved? What about something like cosine of arc sine of 2x, let's say. So let's draw a picture of this. Okay, so here's theta. Sine, as you know, is opposite over hypotenuse, okay? So if I wanted to represent this side down here, I would have 1 minus 4x squared, the square root of that. Okay, so the cosine of the sine of the arc sine of 2x would be this answer. It would be 1 square root of 1 minus 4x squared. Okay, so things like this you're expected to know, okay, from previous classes. Okay, one just for the heck of it. So let's say we have tangent. Okay. Oh, let's do sine of arctan of 5x. So, okay, tangent, as we know, is opposite over adjacent. So then this side here, using the Pythagorean theorem, would be represented as the square root of 1 plus 25x squared. So the sine of my theta here, right? Theta is arctan of 5x. So my sine would be opposite over hypotenuse. Okay, derivatives, you need to know derivatives. So that's also prior knowledge. Okay, I haven't even gotten into integrals yet. And integrals with inverse trig is definitely difficult. Okay, so let's say you're figuring out, all right, the derivative of arctan x over 3. So you'd have 1 over 1 plus this quantity, this is your u, squared, times, you have to use the chain rule, times 1/3. Okay, so if I multiply that denominator by 3, I get 1 over 3 plus x squared, right? I'm multiplying. I have x squared over 9 times 3 here. So that's 1 over 3 plus x squared over 3. Okay, this is a mess. So let's clean this up. 3 over 3. So they'd be likely to write the answer as 3 over 9 plus x squared. Okay, so just keep in mind that you need to be able to get derivatives as well. All right, so let's move on, okay, to integrals. So the easiest way to integrate when you have inverse trig functions, okay, is really to memorize these two rules. If you see an integral of this form, 1 over the square root of some constant squared minus, okay, a variable squared or a variable expression squared, this would be arc sine, and you're just going to get the square roots. Square root of u squared over the square root of a squared plus c. And then for arctan, we would have an integral that looks like this, or that we can make into looking like that. And so that rule would be 1 over the square root of a squared, so 1 over a times arctan u over a plus c. All right, kids, so let's take a look. And I will show you another way to do these problems as well. If you're more of the conceptual type person, you want to understand where these came from, okay? Okay, so integrate. All right, we're going to find the antiderivatives here. So let's get the integral of dx over 4 minus x squared. Okay, so if we do this with the rule, and then you can choose how you want to do this, this is going to use this rule. 1 over the square root of a squared minus u squared du is arc sine u over a plus c. All right, so in my case, I end up getting arc sine. Okay, u is just x, a is 2 plus c. Okay, so the old-fashioned way would be the following. I'm going to factor out, I'm going to start over, but I'm going to factor out a 4. If I factor out a 4, I have 1 minus the quantity x over 2 squared, and we've done this in class. So think about it. You need that 2 in the denominator, right? Because I'm factoring out a 4. So if I'm taking out a 4, I need to put a 4 in that denominator. And so 2 squared is that 4. Okay, so now if I take that square root of 4 outside, I have 1/2 the integral of dx over the square root of 1 minus the square of x over 2. Okay, so we're going to do a u sub, u equal x over 2, du a half dx. Now, I do have a half dx. See this? That's your half dx. So that is going to be replaced with a du. And then I'm going to have 1 minus, and I'm going to replace x over 2 with u. Okay, so this would be my new integral, and then I would just say, oh yeah, this is arc sine u plus c, and then I put my u back in. So you see where the rule comes from, guys? So if you want to do a u sub, you can. It is definitely time consuming. Okay, so let's look at an arctan one. All right, so we're going to do a rule first, and then we'll do it the old-fashioned way. So the rule for this is if you have an integral of this form that I'm writing down here, it's just 1 over a arc tan u over a plus c. So I could just say, okay, yeah, this integral is 1/3 arc tan x over 3 plus c. And you're done. Okay, that's the advantage. So if you don't do it that way, if you do it the old-fashioned way, it does definitely pay to memorize these. So if I do it the old-fashioned way, I start off, I have dx, I'm going to factor out a 9. So then I'm left with 1 plus x over 3 squared. Agreed? So now you do a u sub, u equals x over 3, du is 1/3 dx. So do you see that you could take this, you could take a third out, right? And then I have dx over 3 times 1 plus x over 3 squared. Okay, does that make sense to you? So now, this 1/3 dx is just going to be replaced with du. Okay, over 3 times 1 plus, Okay, this is u squared. So then when you go to get this integral now, this would just be 1/3 arctan u plus c, which is 1/3 arctan, put your u back in, x over 3 plus c. So you see where that 1/3 comes from now, kids? All right, let's take a look at a couple more problems. So those are considered beginner problems, I know. Let's take a look at a problem where the rule doesn't work. Okay, so let's say you have the integral of dx over the square root of 4 minus 25x squared. So the problem here is it's not just an x squared. If it were, we'd be able to use the rule. Okay, so what we have to do here, you have to do this the old-fashioned way to really see it. So I'm going to factor out this 4 in the denominator. So I have the square root of 4 times 1 minus, this is going to be 5 over 2x squared. So now I'm going to take that outside, so I have 1/2, right? Dx over the square root of 1 minus 5/2 x squared. So let me do a u sub, so I'm going to let u equal 5/2 x. So therefore du is 5/2 dx. Now this half dx matches up, but this 5 doesn't, right? So I need to divide both sides by 5. So I have du over 5 is dx over 2. So when I go to write this new integral, I'm going to have a 5th outside, du over, and we already said that we're going to replace 5/2 x with u. So I have du over the square root of 1 minus u squared. Okay, but as you know, that's arc sine, u plus c. And now I put my u back in, so I get 1/5 arc sine 5 over 2 times x plus c. So here I couldn't just directly use the rule, right? It only works, okay, when it's just u squared, when it's the letter, whatever you're showing respect to, that squared. That 25 was a problem. Now, there is another way that we could have dealt with the 25, where we could have used the rule. And I don't know what your preference is, so I'm going to show you this, and then you guys could choose. I could factor out that 25. So if I did that, let's look at what we would have. Dx over the square root 25 times, this would now have to be 4/25, because that needs to be worth 4 minus x squared, right? So then I'm going to take that 1/5 outside, just to make this look better. Dx over the square root of 4/25 minus x squared. So now this is a constant, this 4/25. So now I could use the rule, but I'd have that 1/5 in front, you see? So I wouldn't lose that 1/5. So I'd have arc sine u, which is my x, over the square root of 4/25, which would be over 2/5. And so then I could get to my answer that way. Okay, that's up to you. Okay, let's take a look at an even more complicated one. I'm sure you're just thrilled to death about that. So we have dx over x squared minus 4x plus 7. So what we're going to do here is we're going to complete the square. So I'm going to complete the square here. So I'm going to make this dx over x squared minus 4x plus 4. Okay, so what I did is I took half of negative 4 and squared it. But I can't just add 4 into a problem, right? So if I add 4, I have to subtract 4. So now I get dx over the square of x minus 2 plus 3. All right, so if I'm taking a look at this here, right, I have to figure out what to do from this point. So I have this 3 over here. I also have this x minus 2. So I am going to have to do a u sub. So first let me take out that 3. So if I take out that 3, I have dx, okay, over. Now you need to think about it here. If I take out a 3, I'm going to have x minus 2 over the square root of 3 squared. Process that for a second. Make sure that makes sense, because I need this to be worth a 3. When you square it, it's worth a 3. Okay, plus 1. All right, so you can take that 1/3 outside. And so then I have the integral of dx over 1 plus this quantity, x minus 2 over rad 3 squared. So now when I do a u sub, I'm going to let u equal x minus 2 over square root of 3. So du is just 1 over rad 3 dx. So I need rad 3, du is dx. So now I go back to the problem. I have that 1/3. And then I'm replacing the dx with rad 3 du. And then I have 1 plus u squared. So now I have square root of 3 over 3, arctan u, and I can put my u back in. Okay, plus c. All right, let's take a look at another complicated example here. So I have the integral of 1 over the square root of negative x squared plus 6x. So first I'm going to take out a negative 1 here before I complete the square. So I have 1 over the square root, negative 1, times x squared minus 6x. All right, when I go to complete the square, I'm going to have 1 over the square root, right, of negative 1 times, okay, so completing the square, this is going to be x squared minus 6x plus 9 minus 9. Okay, it's just an algebraic manipulation. So that's the same thing as 1 over the square root of negative 1 times the square of x minus 3. Okay, minus 9. Now I'm going to distribute that negative 1 back in. It's just easier to complete the square by factoring it out. So I have dx over the square root, that's going to be positive 9 now, minus the square of x minus 3. All right, so I could take out 1/3 here, all right? I could take out this 9. So if I do that, let's see what I get. I get dx over 9 times 1 minus the quantity x minus 3 over 3 now squared. Okay. So that, oh, I wrote dx twice. Okay, that 9 can come outside as 1/3. So I have 1/3 the integral, dx over the square root of 1 minus this quantity squared. So now I do a u sub. So I let u equal x minus 3 over 3, right? So du is 1/3 dx. So I already have the 1/3 dx. So this new integral is going to be du over, okay, the square root of 1 minus u squared. So as you know, that is the arc sine of u plus c, and then I have to go put that back in. So x minus 3 over 3 plus c. So I'm going to do a couple of more problems, okay, which are a little beyond the scope of this course. You're not required to watch these last two, but this is for the kids that really want a challenge, okay? And I may put questions on like this for extra credit. So, these are two really difficult problems. I have x plus 2 over the square root of 4 minus x squared. So I can split this up into x over the square root of 4 minus x squared dx, and 2 over the square root of 4 minus x squared dx. So if I look at the first problem, right, I could let u equal 4 minus x squared, so du would be negative 2x dx, and that's a close match. I need this negative 1/2 here. So this integral would become negative 1/2, and then I'd have du, okay, over u to the 1/2 power. So that this gets done separately, so you know this is just u to the negative 1/2, right? So I bump that up 1, so I get u to the 1/2, and when I divide by a 1/2, it's going to cancel with this 1/2. You see that? So I just get negative rad u, and u is 4 minus x squared. So that's what I get from that part of the problem. Now for the next part of the problem, I have to take out my 4 in the denominator. I can also take this 2 outside. So when I take out that 4, I have 1 minus x over 2 squared, right? So now I'm going to take out that 1/2. So if I take out this 4 here, right, that becomes a 1/2. So I just end up with the integral of dx over the square root of 1 minus x over 2 squared. So I let u equal x over 2 here. Notice it's totally different. I had to catch a bigger fish on the left of this problem. So du is 1/2 dx, so 2 du is dx, right? So I have the integral of, I have 2 times the integral of du over the square root of 1 minus u squared. Okay, as you know, that's arc sine. Then I put my u back in, and now I bring down the other part of the problem. So this was a super complicated problem because you had to split it up first and then you had to integrate. All right, guys, here's another awful problem, or fun. I don't know. I find the awful problems fun, but what can I tell you? All right, I'm not saying that you necessarily have to dedicate your time to this, because I'm sure some of you are in 5 AP classes. We've talked about that. But even so, you may want to watch this video just to check it out, just to see how you would approach a problem that's this complicated. So you split it up, like we did in the last problem, into these 2 integrals. All right, so let's take a look at completing these squares. Now, 25, you can actually just think of, you want to have the 16, right? So you can just think of this 25 as being 16 plus 9. So in that case, we have x plus 4 squared plus 9. All right, and then over here we have our 5 over x plus 4 squared plus 9. Okay, so for this question here, right, this is overly complicated. So if we said that u is equal to x plus 4, then du, well, before we even do that, you know that u minus 4, okay, would be equal to x. So we can go back to this problem. We also know that du is equal to dx. So this is the backwards u sub. So this 2x, I'm going to make this 2 times u minus 4. Now the denominator, I'm going to make this u squared plus 9, okay, du. All right, so then you would have to integrate this. Take that 2 outside. So here I have u minus 4 over u squared plus 9, right? But now I would have to split that up again further into u over u squared plus 9 minus 4 over u squared plus 9. So when you're looking at this, right, on the left of this integral, you would have to, all right, let u, so I'll use some other variable. I'll let k equal u squared plus 9 on the left. So then dk is 2u du. So that new integral on the left is just going to become, the 2u du becomes a dk, so I have dk over k. So this is just going to be ln k, right? Absolute value k. Okay, but ln k, as you know, k is u squared plus 9, right? So it's ln u squared plus 9. You don't need the absolute value then. But u is x plus 4. So this is ln x plus 4 squared plus 9. Okay, for that part. Then for the next part, okay, the next part's actually not too bad. So then we have minus 4, and we can use the rule, okay? So we have the 9, so the square root of that would be 3. So that's 4/3. That's from 1 over a. Arctan, okay, u over a. But then you have to put your u back in, guys. So you would still have to replace that u. Okay, so that u was x plus 4. So just keep that in mind. That would be x plus 4 over 3. Okay, meanwhile, over here, you would have to finish up this integral. So now you know how to do that, right? Take out your 5. And then we can also take out this 9. So if I take out that 9, we have 1 plus x plus 4 over 3 squared, right? So I'm taking that 9 out front, guys. So I have 5/9 dx over 1 plus, okay, that square. And then I would have to do a u sub, right? So I'd have u equaling x plus 4 over 3 du 1/3 dx. Now technically I could make this 9 3 times 3 so that I could replace this part here with just du. Okay, so then my new integral would be 5/3 du over 1 plus u squared, which would be 5/3 arctan u plus c, and then I'd have to put this u back in. So that'd be arctan x plus 4 over 3, okay, plus c. And don't forget I have this part at the bottom, and then you see that these are like terms, kids. This, right, minus this. So then the final answer would be, okay, ln of x plus 4 squared plus 9, and 5/3 minus 4/3 is 1/3, plus 1/3 arctan x plus 4 over 3 plus c. All right, that concludes this video. Thank you.